Hi guys, so we are today chipping away at the knowledge of vectors just a little bit more. Today we're going to focus on vector direction. A vector has two components. It has its length, which is usually referred to as its magnitude, and then it has the direction that it points. And in a normal class day we'd cover both at one time, but we're kind of breaking it down. We're just going to do vector direction today. Essentially, there's a few different ways to talk about direction depending on your perspective, and we're not going to float different perspectives. We're just going to talk about what is the vector's angle to horizontal. So that means if we have a component vector that starts at the origin, as many do, we're looking for this angle right here. And it is very similar to standard position angles that we learned in trigonometry. For a vector where we're given a beginning point and an ending point, we're thinking of a hypothetical horizontal, and we would want this angle right there. It would be as though we would sort of transpose this over to here and then find that. So that's what we're going to be focusing on today. It sounds kind of difficult. It's really not. I had to review it a little bit because it's easy to forget all the steps. But hopefully learning it this way online for a couple of days, get some good working knowledge of it, you should be fine. So we'll go down to here. We'll see that the first two examples I'm going to do are the type that have the beginning point, end point. So here A is the beginning point, B is the end point. You can tell because the arrow is over it. And then here, number 4, RS. Then we've got two component vectors, which are where you assume the beginning point is the origin, and then we have two in linear combination form, or the IJ form, which if you've been working right along, is basically the same thing. These are just two different ways of writing the same kind of thing. You'll notice a radical down here, in your homework, one problem is going to have a radical in it. That's not going to be too challenging. It's nothing to really worry too much about. Okay, so 2 and 4 are the most work. Once we get through 2 and 4, this is actually going to go quite a bit easier. But the first thing we're going to do is we're going to convert it to a component vector. So if you recall, you start with the end point minus the beginning point or initial point. And so when you do this, 1 minus 10 is negative 9. 1 minus minus 6 is positive 7. And I put those funky brackets on it. Now that I've converted it to this, everything from this point on is going to be the same when we get down here. And then remember that these are essentially the same thing too. So the reason problems 2 and 4 are more work is because you have to do this step first. Okay, the next thing you want to do is sketch a graph. It doesn't have to be super accurate. It can be kind of a loose graph, but just somewhere on your paper where you got a little room, put a cheap? Yeah, don't pay for it. Small little XY axis, and plot negative 9, 7. So negative 9, 7 is going to be, let's see, left 9 would be negative 9, up 7. So let's say it's right there. I'm obviously not drawing it to scale. We essentially just want to know what quadrant it's in. So the angle we're trying to find is right here, the size of that angle. Well, it's been a while, but we totally covered how to do this in trigonometry. When you're trying to find an angle like that on the XY axis doing coordinate geometry, you can, well, we have this relationship that we learned before, that tangent of an angle is equal to y over x. I don't want to drag this on too much, but if you look at this as a right triangle, okay, here's our angle right there. I know we're trying to find this angle. Forget that for just a minute. This is part of the steps that go into it. But anyway, the y-coordinate 7 is like your opposite, and the x-coordinate negative 9 is your adjacent. Opposite over adjacent, or y over x, is tangent, which means if we want to know what theta is, we can do the inverse tangent of y over x. Now, if you're starting to have horrible flashbacks to trigonometry or things you didn't like, this is all you do. We don't use sine, we don't use cosine, we don't do a big analysis. Inverse tangent is the tool. It's the step that we use every time. Okay, now I am going to flash back to a little bit of stuff you might not like. We did learn that inverse tangent really only exists in the fourth quadrant and the first quadrant. We talked about how all of the inverse functions have certain domains they work in. And so the second quadrant was not one of the quadrants where inverse tangent is supposed to be, and neither is the third quadrant. However, vectors can point any direction. I mean, there's no restriction on the direction vectors can point. So there is a little trick you have to do to make this work out better, but it's really nothing. It's not a big deal at all. So the trick is you treat this as though it's a triangle, not on the xy axis, but just a physical triangle. And I'm going to be erasing this, but in a physical triangle, you would say, okay, this height is 7 and this base is 9. You wouldn't call it -9 because it's not on the xy axis. You just call it 9, make it positive, run through your formula, your inverse tangent, and then you figure out how big that angle is. So the fact is, oh, my dog just ran into the room. When you're doing this work here and you've got negative numbers, oh, he jumped up on me. Goodness, you're in for a treat today. Okay. You're going to have negative numbers. It's going to come up. It's going to happen. So plot them correctly, -9, 7, not necessarily to scale, but use the negative to get it in the right quadrant. But then once you're there, you don't have to worry about the negative anymore. So here, let me cut to the chase and show you how to do this. We are going to do, let me get back to the right color, the inverse tangent of y over x, that's 7 over 9. So you don't do the negative. Inverse tangent. Oh, also, don't forget to make sure you're in degrees. We're going to go ahead and do all of our answers in degrees. We're not working in radians at all. So remember that little wrench up there in the upper corner, and then select degrees. Okay, so 7 over 9, and you get 37.87 degrees. Okay, that is how big this angle is. Here, I'm going to actually change colors. This angle right here is 37.87 degrees. But the angle of the vector is right here. That's what we're trying to find. So, what can we do? Well, remember the x-axis is a straight line, and a straight line is 180 degrees, so you can take 180 minus 37.87, and that'll give you this theta measurement right there. So 180 minus 37.87 is 142.13. So the direction of that vector is 142.13 degrees. Let me come down here, and you see it right there. Okay, so I did a lot of over-explaining in that one. Number 4 I'm just going to work through the steps that matter, and it can be something that you can just copy, follow along and do yourself when you have to do your own homework problems. So, first thing you want to do, endpoint minus initial point, or terminal minus initial. So -8 minus -1 turns to +1. That's -7. 9 minus 5 is 4. So we're going to sketch a little graph of the component vector -7, 4. -7 is this way, 4 is up. So it's a lot like the last problem. It's going to be in this quadrant. Now the first thing we're going to do is find this angle, the inverse tangent of 4 over -7. Okay, what did I do? We're just going to use positives. So inverse tangent of 4 over 7. So this angle over here is 29.74 degrees. If we want to find this angle, the angle of the vector, that's our theta, theta is going to equal 180 minus the answer we just got, 29.74. So 180 minus 29.74, 150.26 degrees. Let me check the answer down below. Yep, 150.26 degrees. Now, my first two examples both ended in the same quadrant. What happens when you get angles in another quadrant? That's going to come up as we go through some of these problems here. Okay, so number 6. This is already a component vector, so I can go straight to drawing my graph of it. 27, 10, they're both positive, so you go over 27 and up 10. You get a vector in this quadrant. We want to find that angle right there. Do inverse tangent of y over x, 10 over 27, and see what you get. Let me delete some of these. Inverse tangent of 10 over 27, 23.32 degrees. So that's how big, if this were a triangle, that's how big that angle is right there, 23.32 degrees. But that happens to be the vector angle. In this case, we don't have to subtract from 180. We're in the first quadrant. The answer you get is the answer. So for number 6, that should just be it, and there it is right there. Let me see. Pardon me for just a second. I want to... Yeah, I think I need to do number 5, to be honest. I'm gonna change things a little bit. I'm gonna ask you to do number 8, and I'm gonna do number 5 instead. So here's my XY axis. And I need to plot the point radical 165 comma negative 14. You might ask yourself, you know, how do I do that? I don't know what radical 165 is. Yeah, you could type it into a calculator, but you don't have to. I mean, it's a positive number. So my x value is a positive number. I'm not drawing this to scale anyway, so I just know it's going to be over there. The y coordinate, negative 14, down here. So my vector is going to be in this quadrant. And I think this is the only example in that quadrant. That's why I wanted to do this one for notes, because if not, you'd be on your own to figure this one out. So, okay, so when I do my inverse tangent, it's going to give me this angle. But the angle of the vector is that angle. So what am I going to do about that? Well, first, inverse tangent of y over x. Y over x is going to be 14 over radical 165. Remember, you just ignore the negatives in the points at this step. You don't need them. If you accidentally put them in, you'll get the same angle, but it'll be a negative. So it could confuse you. Just drop the negatives in the first step, and you're fine with that. If you're looking at this and say, well, you're not allowed to have a radical in the bottom of a fraction, we're not trying to represent that as a final answer. This is just something I'm going to type into a calculator, so it's totally okay to have a radical down there in this phase of the operation. No big deal. So I get 47.64. This works out to be 47.46 degrees. Not 64, 46. So that's how big this angle is, 47.46, as though this were a right triangle. How do we find the vector angle? We're going to subtract it from 180? No, because when you're in that fourth quadrant, what you're really doing is you're comparing it to essentially a full circle. If you have a full circle, you subtract out this bit here, it gives you the leftover. So to find the vector angle for this problem, I need to do 360 minus 47.46. Of course, those are all degrees. 360 minus 47.46, 312.54 degrees. All right, let me check number 5, and there it is. Okay, so this is extremely, extremely similar to the trig that we have been doing. So I'm really, really hoping it doesn't give you too hard of a time. All right, let me go back to doing some of the evens. So I'm going to ask you to do number 8 since I did number 5. Let's look at number 10. So if I want to graph negative 24, 32. Okay, that works. let's see, so this is like your x and this is your y when it's in the ij form. So negative 24 is over here, 32 is up here. My vector is in the second quadrant. So number 10 actually works out to be a lot like 2 and 4. Those are both in the second quadrant. This one's in the second quadrant. Did I say third quadrant a minute ago? If I did, I'm sorry, second quadrant. So when I do my inverse tangent, it's going to give me this angle. I'll subtract that from 180 to get the actual vector angle. So inverse tangent of y over x, and again, just drop the negative. So function inverse tangent 32 over 24. So this little angle over here is 53.13 degrees. My vector angle, if I want to call that theta, I guess I didn't do that on every problem, but if I want to call that theta, theta is going to work out to be 180 minus the 53.13. Use a calculator, 180 minus 53.13, 126.87 degrees. So this vector angle, 126.87. There it is. And that takes us to number 12. Number 12. Remember, the first number is like an x value, the second number is like a y value. So when I plot this, negative 21, negative 9 radical 23. Negative 21, the x value is going to be over here. Negative 9 radical 23, I have no idea what it equals, but it's going to be down here. So you do need to take into account this negative when you're graphing it. It's important for this step. That tells us the quadrant that the vector lies in. Now to find our vector angle, we need this angle right here. Again, from the positive x-axis rotating around. That's our vector angle. That's our theta. When we do the tangent or inverse tangent step, it's going to just be treating this as a right triangle, and it's only going to be giving us that angle right there. So my first step only gives me this angle. Let me go ahead and do that. Inverse tangent of y over x, 9 radical 23 over 21. Again, I'm just neglecting or negating or getting rid of the negatives. Inverse tangent, 9 radical 23 over, oops, all right, that's no good. I have to hit the divide button first. 9 radical 23 over 21. So that's a 64.06 degree angle. Now, how am I going to find, let me change even a different color here, this angle? Okay, well, to find that angle, I'm going to keep in mind that from here to there is 180. So if I want to get this 180 and then 64.06 degrees more, oops, that autocorrected autofilled a circle. If I want to get 180 to here and then another 64 more, in this case I'm going to have to add. So my theta, my vector angle, is going to be 180 degrees plus 64.06 degrees. So 180 plus 64.06 gives me a measurement of 244.06 degrees, number 12, and there it is. So this is very closely related to the reference angle business that we've been doing. So the knowledge that you built back then should help. 2, 1, and 3, you're going to have to subtract the vectors, the endpoints, to get a component vector, plot that on the xy axis, and then do that for all of these, plot them on the xy axis, get an idea of where your angle is and what quadrant it's in. The only trig step you're going to do is inverse tangent. Remember that when you get to that step, you only use the positive numbers. So here, let me write this down maybe as a little formula. So if theta is the vector angle, the first angle you get is not necessarily the vector angle, it's a different angle, and then you have to calculate the vector angle. So that's that we can use a different symbol. I believe phi, which is a Greek letter like this. I'll have to look that up. I'll maybe have to correct myself later. So that first step is the inverse tangent of y over x, and you're only using the positive numbers. So you could think maybe you absolute value those. And then so theta, well, in some cases theta actually equals phi. That's when you're in the first quadrant. Well, let's see, quadrants are Roman numerals, so I'll go ahead and do this. Wow, I'm smart. Roman numeral 1. So I'll do Q1. We're in quadrant 1, theta equals phi. That is like, which problem was it? Number 6. The answer you got from the first step was the final answer because you're in the first quadrant. So this was like number 6. Theta is going to equal 180 minus phi if you're in quadrant 2. And that happened numerous times. That happened in example 2 and 4 and 10. So numbers 2, 4, and 10. Theta is going to equal 180 plus phi if you're in quadrant 3. And that happened in number 12. And then theta will equal 360 minus phi if you are in quadrant 4, like number 5, problem number 5. Okay, so the math you're doing is pretty straightforward. We've got a couple problems where you have to subtract. We're doing inverse tangent on the calculator. Make sure you're in degree mode. And then again, you might add or subtract with 360 or 180, or maybe you won't have to do any other follow-up steps. So the math is very simple, but it's very new in a sense. Even though we've done some analytic trig like this before, it's fairly new. So, follow my examples. Try to, use these notes up here. That might be pretty helpful to carry through and get you through this. And by all means, ask me questions. So I'm going to ask you to do numbers 1, 3, 7, 8, 9, 10. 1, 3, 7, 8, 9, 10. Here, I'll highlight those. I'll highlight those in red. Do 1, 3, 7, 8, 9. Get rid of that. And 10. All right, contact me if you have questions. Remember, you have no new work on Wednesday, so you can work on this today and tomorrow. If you get stuck, you can email me if you have questions. I could maybe post an extra help video, or I can get in Google Meet or something like that and help people out. All right, so good luck, and